Dr. Mears. Today we are going to be finding probabilities by rolling a die. Does anybody know what these little dots are called? These are called pips. So here there's 4 pips, there's 2 pips, there's 6 pips, there's 3 pips. This is also a fair die. A fair die means that each side is equally likely to come up. That is, that each side has the same probability of coming up when you roll it. So let's get going and finding some probabilities. The first thing when we find probabilities is we have to find the sample space. So remember, our sample space are all of the outcomes that are likely to come up. So let's take a look at our die. It has 6 sides. Let's see. We have a 1, a 2, a 3, a 4, a 5, a 6, and that's it. 6 sides. So we have numbers 1, 2, 3, 4, 5, and 6. And that's our sample space. I like to use these fancy little brackets. Okay, so in our sample space, it is comprised of 6 numbers. So our sample space is 6. So the number of observations that I have here, or the number of outcomes, remember we like to use the same word to represent different words to represent the same concept. 1, 2, 3, 4, 5, 6. A total of 6. Okay, let's go on and find some probabilities. So if we want to find the probability of the event of rolling number 1, little tongue twister there. If we want to find the probability of rolling a 1, which our event is rolling a 1, we have to use our rule number 4, which was how many ones on the die divided by the total number of samples, or the total number of numbers, which is our sample space. So how many ones are there on our die? There was only 1, and that only came up once. Okay. How many total numbers do we have? We have 6. So we have a 1 out of 6 chance of rolling a 1. We can reduce this, and when we divide it out, actually we can't reduce it, we can divide it out. When we divide it out, we get 0.166666 repeating. So if you would like to, you can round that to 0.17. Absolutely fine. If you want to change it into a percent chance, we have a 17% chance of rolling a 1. Okay, well, let's do all of the others quick. Probability of rolling a 2. Well, there's only 1 2 in our sample space, so there's only 1 2 out of 6 total, so 1 out of 6. Same exact as our probability of rolling a 1, which is 0.17. Well, probability of rolling a 3, again, 1 out of 6. There's only 1 out of 6 total. Probability of a 4, again, 1 out of 6. Probability of 5, again, 1 out of 6. And lastly, probability of rolling a 6, 1 out of 6. So notice, each one of these has the same chance of being rolled. And that's what I meant by a fair die. We don't have, it's not weighted, which means that the 2 isn't going to come up more often. The 2 is going to be rolled as many, we have the same probability of the 2 being rolled as any other number. So this is a fair die. Okay, let's look at some other probabilities. I'm going to make a little break right here. Let's find the probability of rolling a 1 or a 2. Okay, so remember, it's the outcomes divided by the total number. We have 6 in our sample space. How many 2s? So we have 1, 2. That's it. So we have a 2 out of 6 chance of rolling a 1 or a 2. We can divide that out to be 0.3. Oops, I was saying 0.3. We can divide that out to being 0.33, or a 33% chance. All right. How about the probability of a 1 or a 2 or a 5? Well, we know in our sample space there's 6 numbers, and 1, 2, 3, there's 3 outcomes. So that's a 3 out of 6. 3, 1, 2, 3 out of 6 total. So the probability of a 1 or a 2 or a 5 is 0.50. Okay, let me throw this one at you. How about, I'm going to leave that right here. the probability of a 1 or 2 or 3 or 4 or 5 or 6. Let's say I was going to give you $1,000. $1,000 if you rolled a 1 or a 2 or a 3 or a 4 or a 5 or a 6. Would you take it? Oh, I would take that bet. Heck yeah. Because we know there's 6 outcomes. Well, here's outcome 1, 2, 3, 4, 5, 6. So we have a 6 out of 6 chance. That is a probability of 1. We could have also done it like this. We know the probability of a 1 is 1 out of 6. We know the probability of a 2 is 1 out of 6. We know the probability of a 3 is 1 out of 6. Oops. 1 out of 6. We know the probability of a 4 is 1 out of 6. Probability of a 5, 1 out of 6. And the probability of a 6, 1 out of 6. What do those add up to? 1, 2, 3, 4, 5, 6. 6 out of 6, which gives us a probability of 1. So if somebody says, I have a 6-sided die, and if a 1, 2, 3, 4, 5, or 6 comes up, you win, take that bet. Okay, well, let's see. What's the last one? Ooh, this one right here. Probability of a 1 and a 2. Now, remember, we have a die, okay? So we can get a 4, or we can get a 1. We can get a 1, or we can get a 2. I want a 1 and a 2 at the same time. You can't do a 1 and a 2 at the same time. The die just doesn't fall like that. We have a 1 side, we have a 2 side, and that's it. So there's no sides that have a 1 and a 2 on this dice. There's no sides that have that. Using this dice right here. We have 6 possibilities. That gives us a probability of 0. So if somebody asks you to take that bet, don't take that bet. Don't take the both bet, especially when you're using a die. This has been finding probabilities using a 6-sided fair die. Adding them up, as you can see, if we add up the probabilities of all the numbers in our sample space, we get 1. If we try to find both, we just don't have that on here. That's a probability of 0. And we also found the individual probabilities, 1 through 6. And then look to see what happens if we have or. And we found that we can simply add those up as well. This has been probability rolling with a fair die. Hope it helps. Thanks.